Hi everyone, I'm Scott Delandy with the product management team for the PowerMax business unit, and I'm joined here today with Rob Tasker, part of the corporate system engineering team for the PowerMax business unit. How you doing, Rob?
Good, how are you, Scott?
Excellent. So, big launch, we've got the new PowerMax systems that we're introducing. We've got two models. Can you take a second just to explain what those models are and what they include from a scalability perspective?
Sure thing. If you take a look at our image, we've got the PowerMax 2000 and the PowerMax 8000. And the 2000 can have up to 2 power bricks and all the way up to 4 controllers. And the great thing is it can fit in a half a rack,
okay,
which is great, and it goes up to 1 petabyte. The 8000 is the big machine, and it can go up to 8 power bricks and all the way up to 16 controllers as well, and it can reach 4 petabytes.
So each power brick is 2 controllers, and we can put basically a half a petabyte of capacity into a half of a rack.
That's correct.
That's pretty cool.
That is
so
pretty cool.
What are some of the cool hardware features that we're introducing on this platform?
Sure, so we're transitioning the back end to all NVMe. So we're not using the standard solid state drives that we use in the all flash systems today. We're using NVMe drives.
So that's more high performance for the back end of the system.
It sure is.
Excellent. And what else do we have?
So we're adding something called data reduction.
Okay, data reduction. And what does that include?
So if you, in the existing all-flash systems, we have something called the adaptive compression engine.
Okay.
So we're adding deduplication to that, and we're putting it together to create data reduction.
So it includes compression and deduplication.
That's correct.
Okay, and how does that run?
It's inline. So
inline.
It's all inline. There is a hardware assist module that we use that performs the compression and the deduplication as an inline process.
Very, very cool.
Awesome.
Okay, Rob, so let's drill into the new data reduction capability. So what's really new here?
So we have a few things, and we'll start with, we have a new inline hardware assistance module.
Okay, so and what does that do?
That's actually the module that performs the compression and deduplication, and the cool thing is it does the dedupe and the compression at the same time.
And that's done in hardware, right?
Yes, it is a hardware module.
And what does that mean?
So that means it is inline, and it is truly inline, and it allows all of our other data features to be supported as well.
What about performance?
So there's no impact to performance, because we're still using one today as well.
Okay, so that means for most applications, you're going to get a millisecond or even better in terms of response time.
That's right, right.
That's cool. What else do we have?
So we're changing our compression algorithm within the adaptive compression engine as well. We're switching from the current LZS algorithm to something new called the deflate algorithm.
Okay, and what does that get you?
So the reason we're doing this is because we expect to see about 15 to 20% improvement in the efficiencies that we see.
So better compressibility.
Absolutely.
Awesome. What else do we have?
So as I've mentioned a couple times, we're adding inline deduplication as well.
Okay, and that inline deduplication, that's an inline operation. So is that for every I/O that comes into the system?
That is correct. As long as we enable the data reduction feature on that application with the storage group, you get both inline compression and inline deduplication for every write and every I/O that comes in.
So when we combine, the hardware assist with the new compression and the data deduplication, what do we expect to see from an efficiency ratio?
So overall, we should see an improvement to about 3 to 1.
3 to 1.
Yeah.
That's pretty good.
It is.
Excellent. Okay, Rob, so we have an inline hardware assist, we have new compression algorithms, and we have deduplication. All right, I got to ask the question, how's it work?
Sure, it's actually quite simple. So remember, it is inline, right? So we have the new inline hardware assist module that we have. And if we take a look at our image, we have an I/O coming in from an application or a host. And it comes into that assistant card, that new I/O module we're using, and the data comes through. We get the compressed size of that data, so we have compressed data over there. And then we also get the dedupe hash ID as well. So then after we have all that information, we take the compressed data and we put it on disk. And now you can see in the bottom we've got the SSDs and the super fast NVMe backend.
Okay, so but because it's deduplication, if I already have a copy of the data written on the storage, what happens then?
It's a great question. So then what happens, we have another I/O come in, we have another host I/O that write, and it's writing the same data.
Okay.
So when we get through this and we get the dedupe hash ID, before we actually put the data onto those drives, we do a comparison of that dedupe hash ID.
Okay.
And if it already exists somewhere, we don't bother allocating it to disk, we don't waste the space. If it doesn't, we update some hash ID tables and we put it on disk.
Okay, but if the data is already there, then we just, I assume, take the metadata and we point it to the data that's already there. So if the application needs to read it, it thinks it's reading the data that it had written, but it's actually reading the data that was already written there to begin with.
That's exactly right. That's essentially what dedupe is, taking many copies of the same data and giving them one place to live so that the the applications that are reading them think they're reading their own data, when in actuality, they're all sharing the same data.
And that happens for every I/O coming into the system. Every new write coming in gets deduped and compressed.
That's correct. As long as the data reduction feature is enabled for those storage groups, then they will get the benefit of both functions.
That's really cool.
It is really cool.
Okay, Rob, so we talked about what's new and we covered how it works. But from a user perspective, how is it managed?
Sure. At the storage group level, it's enabled and disabled just like it is today.
Okay. But by default, it's on?
It is on by default when
Okay.
you're provisioning to host. It is a function that's automatically on by default.
And why would a user think about turning it off?
So there are some data sets that just simply don't compress and they're not dedupable. And if the customer or the user is aware of that up front, they don't have to turn it on. They can disable it by choice.
So something that's like encrypted at the application level is not going to dedupe and compress, so why bother to turn
That's a
it
great
on?
example, Scott. That's
Okay,
perfect. If they know their host is encrypting the data, there's no sense in sending it to the box to be compressed because we wouldn't be able to compress it.
Okay, what about reporting? How do I actually see what my data efficiency is at?
Sure, within our management tools, we report the efficiencies at the system level and as well at the storage group level. So you can see individual storage groups and how they're doing.
So I can, at the individual storage level, I can see what the compressibility is at the application level, but then I can also roll that up and see what I'm getting across the entire box from a data reduction perspective.
That's correct. In fact, actually, with the storage group level, we have two things that are really cool that we show you. What you're currently achieving for an efficiency. But if you did happen to disable the data reduction feature at your storage group level, we have a display that covers your compressibility so that you can say, hey, wait a minute, I have this application, and according to this display, it could give me even better savings. I should go turn it on.
Right. So it's actually based on the actual data sets that's running on the system, so it gives you a real-time measurement of what the potential efficiency could be just by going in and checking that box.
Absolutely, yeah.
Okay, what about data services? Does everything work?
Everything works. So because it's truly inline data reduction, inline compression, inline deduplication, all of the data services offered in the current VMAX all-flash and all the data services offered in the PowerMax systems is supported today.
So that means the replication, snapshots, remote replication with things like SRDF. I don't have to change anything. I just go ahead and I turn this feature on and I just get better space efficiency.
That's absolutely correct, yeah.
Okay, what about security? How does this impact security? Because, you know, if I have data that's encrypted, then I can't compress or dedupe it. But what if I need to encrypt the data?
Sure, so we offer DARE, which is data at rest encryption, and because we're truly inline, as I've mentioned a couple times already, we actually do all of this data efficiency before we encrypt the data. So we still support DARE as well on the back end.
So I can enable the dedupe and compression functionality, and that doesn't impact anything on the compression at the drive level?
No, not at all.
All right, Rob, this is super awesome. Where can we go to get more information?
Sure, so for all of the features that are coming out with the next release, there will be collateral available on DellEMC.com.
Okay, so I can just go to the website and I can pull up white papers, additional videos, documentation, all that great stuff.
Yeah, it'll all be there.
Okay, cool. Rob Tasker, Corporate System Engineer. I'm Scott Delaney from Product Management. Thanks for joining, and we hope to see you again real soon.